This video is a gold mine. Over a week of research, tests and experiments to understand how to bake a high poly model into a low poly model on hard surface objects. If I've spent so much time getting it right, it's because internet resources don't tell the whole story. The cases presented are always simplified cases, such as baking a cube. The reality is far more complex. You will also find tutorials on how to bake objects without bevel, which is obviously much easier. And above all, the vast majority of tutorials, even those produced by Blender addicts, don't bake in Blender but in Substance Painter. In this tutorial, we will bake a real model with real challenges, bevels and Ngons, and we will do it entirely in Blender, not in Substance Painter. Then we will test it directly in Unreal.
South, share knowledge, grow together.
This tutorial focuses on workflow and baking. I won't go into step-by-step detail on how to model the example object. The only important thing is that the modeling is done with Fluent. The addon features tools that allow us to modify the model's resolution in 2 clicks. The main advantage is it's a non-destructive modeling tool, and it's really handy for making modifications without having to start all over again. If you follow me regularly, you know my enthusiasm for non-destructive and procedural work, flexibility, ease of editing, huge time savings. Now that the raw modeling phase is over, I will give you my first tips for optimizing your model for baking. Do you see those long diagonal support edges? They're the bane of your baking and need to be replaced by support edges that are perpendicular to the model edge. Here how it works. To correct the upper part of the model, I select it, isolate it with the slash key, and to see what happens, switch to wireframe view. Switch to edit mode and use the keyboard shortcut Ctrl-R to add an edge to the center of the model. Finally, use the shortcut Shift-F to return to object mode. Repeat for all parts of the model that require it. Edit mode, Ctrl-R, Shift-F, that's your combo for hunting down diagonals. One of Fluent's innovations since its creation has been to take advantage of its non-destructive way to avoid managing bevel resolutions one by one. Press the F key and click on the gear icon. Use resolution to increase or decrease mesh density. About cylinders, the last slider lets you specify a minimum number of segments for a cylinder. In my example, this has no effect because the resolution is sufficiently high. I'm going to apply all modifiers. I select all my objects, press the F key and hold down the Alt key while clicking on the little white flag. You can see that in edit mode, we now have access to the entire mesh. All modifiers have been applied except for the bevel and the weighted normal. I continue by merging all the objects with the shortcut Ctrl-G. I rename the object for greater clarity. Only 2 things left to finalize the height resolution model. If you miss them, your baking will be just awful, so stay tuned. Let's get back to the weighted normal modifier. It's one of the things I've been testing extensively, so I'm going to save you a few hours by telling you to set the main parameter to 100. As a result of research for this tutorial, the parameter normally defaults to 100 as of Fluent version 3. Every opportunity is good to improve the add-on. Finally, add a triangulate modifier with a minimum of 5 and check the Keep Normals option. Let's summarize the main points of this section on preparing the high poly version. Avoid diagonal support edges. Replace them with support edges perpendicular to the model edge. Hard surface models contain Ngons, so use a modifier weighted normal at 100. Otherwise, you will get artifacts on the baking of normals. Finally, add a triangulate modifier with the Keep Normal option. Once again, this isn't the main focus of the tutorial, so I will give you a time-lapse preview of the texturing part instead. The only important thing to remember here is that texturing is performed with the materializer add-on. This is important for what follows, as this is the tool we will be using for baking. If you are not familiar with Materializer, it's a tool that speeds up texture creation by offering a layer and mask-based workflow and many pre-designed nodes for procedural texturing. All the images you can see in my communication for my various add-ons are textured only with this, no image inside. The great thing is that there's no need to unwrap UVs when using procedural texturing, and that's good. Height definition version of the model is now completely finished. Now it's time to prepare the low resolution version. Fluent never deletes anything, and everything is always recoverable. So I'm going to redisplay the non-destructive version of my object by clicking on the A with Shift to redisplay all shield objects in the hierarchy. I suggest you hide all sliced parts. Use search to find and hide them. For the remaining elements, I will hide the Boolean operations that correspond to the slice I have hidden. We continue the simplification by lowering the model resolution. Here, it all depends on your objective, but for the example, I'm going to lower the model resolution to 6, specify a minimum of 4 segments for the bevels. If required, you can also reduce the resolution of the cylinders while specifying a minimum. Well, once you are happy with the template, use the little white flag once more while holding down the Alt key. Before going any further, I remove any unnecessary support edges. I use the shortcut Ctrl X, which will delete both the edges and the vertices along the edges. About modifier, remove the bevel. Check that the normal weighted value is 100 and active Keep Sharp option. Finally, as for height poly, we add triangulate with a minimum of 5 and the Keep Normals option. Well, this time I'm sorry to say that we will have to deal with the UVs. Yes, I know, it depresses me too. So let's try to make it as cool as possible, and I will give you 2 options with or without add-ons. Knowing that clearly using an add-on makes your life incredibly simple and brings much better results. And when I say much better, I mean by factor of 2. When you switch to edit mode, you can see that some of the work has already been done, as the edges are already marked as seams. These are the edges marked in red. However, if you take a look at the UV, you will see a particularly deformed area that needs to be improved. To do this, it's relatively simple. Just select the faces concerned, then switch to edge selection to be able to right-click and add seams around these faces. Press the U button to request a new UV unwrapping. The result is better, more regular, but there are still a few flaws, such as the large, somewhat distorted square. But the biggest problem is the surface covered by the UVs. We are only at 48% utilization of the available surface. This is extremely important to bear in mind, as it means that if you output your textures with a resolution of 2K, only 48% will be used. In other words, it's like you outputting a 1K pixel texture, but you're still going to use memory space for a 2K image. I think you understand how crucial this data is for the quality of your baking and by extension the quality of rendering. I'm now going to suggest that you improve your result by using 2 add-ons. But if you are not interested in a doubling of the fill rate and a reduction of distortion, then use the chaptering in the reading bar to go straight to baking. I would like to show you how to use ZenUV, which is under constant development. Of course, you will find a link in the description to buy this add-on. A very useful thing to do right from the start is to activate the checker texture function, which allows you to visualize the orientation and distortions of a texture used on your UVs. As you can see, the result on this side is particularly ugly. I advise to activate this double arrow, which allows you to make selections either from the UV or from the 3D object. In any case, select the 2 problematic faces and use the Alt-U shortcut to bring up ZenUV's circular menu, then click on Mark to place seams around the face and unfold the UVs again. Let's continue your inspection. Here at the chamfer, we can see that the texture doesn't follow the curvature. We can also see a strong deformation of the texture in this area. So let's fix it. Select the whole object using the Alt-U shortcut and use the Quadrify Relax Hotspot button. You can see that the texture now correctly follows the curvature of the chamfer and that the texture is no longer distorted in this area. But I draw your attention here to the fact that the texture orientation is not continuous. We select all the problem areas and use the Quadrify function once again. The texture orientation is now consistent. I can tell you that if you had to do this by hand, you would spend 10 times as much time on it. All that's left is this face. There are 2 ways to correct this. The first is to select an edge and use the Reshape button. The other, which I particularly like, is to select all UVs and use the World Orient function. All All that's left is to ask for a pack of the UVs, which I'm doing here with ZenUV. The result is much better than before, and we have gone from 48% to 63% coverage. I suggest you go on step further with gain almost 20% more coverage with an additional add-on. Basically, operation is extremely simple. In the options, I activate rotation. In the pixel margin section, I use a 5 pixel margin for a 2K texture. Finally, I activate a 5-second heuristic search. Just click on the pack button and let it do its work. You can see directly on the screen that we have reached 80% fill. So, don't get me wrong, we've gone from less than 50% coverage to 8% plus distortion correction in a ridiculous short time. Again, if you're interested, the links are in the description. Think about it, it supports the channel and allows me to offer more content on something other than my own add-ons. Well, that's it, folks. We're ready to get baking. Baking will be done with my materializer add-on, which not only lets you make great textures, but also allows you to export them for various uses, such as import into Unreal Engine. That's what I will show you next. Display height and low poly. First, select the height, then the low with the control key. What's important here is that the low resolution model is the active object. Go to End Panel in the Fluent tab and in the Shaders section. About resolution, I set 2K, I leave sampling at 16. The margin parameter determines the texture overflow beyond the UVs. Custom color space is an option to activate if you're using something other than Filmic. Typically, if you installed the Access profile. I request PNG and select output maps. Important for the normal map. Knowing that the object is to be used in Unreal Engine, I check the DirectX box, because that's the standard used by the software. As a remember, basic Blender baking produces an OpenGL normal map. I'm requesting the two versions of the normal map, one to be able to view the result in Blender and the other to use it in Unreal Engine. I check the option to have the bake material automatically set to low poly. And now we come to the four most important options. 1. We ask for a bake height to low. 2. Activate the cage option, which is essential for successful operation on edges. 3. Leave the cage object entry blank. Blender will then use the low poly as a cage. 4. Extrusion represents how much the cage must be inflated to contain the height poly. If this parameter is wrong, you will soon notice the result of the normal map will show yellow areas. The button remains grayed out, as you can see from the message in red, because the low resolution version has no material. Blender requires the presence of a material in the low resolution version in order to perform the baking. So we obey nicely, add a material which makes the button available. Here goes. For those completely new to baking, it's a time-consuming operation in terms of computing power. So take the opportunity to go for a drink and come back in a few minutes. Well, that's it in real life, since I'm just going to make a cut so as not to have to wait too long. The button is now gray again, so the operation is complete. We can see that everything has worked well, and that we have the normal from the high definition model with the illusion of soft edges with a bevel, when in fact it's a hard edge. Before exporting, be sure to save your maps. The add-on will try to save them automatically in a texture folder that will be created next to the Blender file. Automatic saving doesn't always work due to access rights issues, so please check. Color is saved. Metallic, true. Roughness, true, but not normal. The little star next to the image button indicates that the image has not been saved. I advise you to save your normals in 16-byte PNG format. As I was saying, we are going to go into Unreal, and I'm going to change the image used for the normal map by requesting the use of the DirectX version. Now it's time to export our model. Click on File, then Export, then FBX. Just so we are clear, my field of expertise is Blender, and what I'm showing you here is the minimum required for demonstration in Unreal. There are probably more subtle details to explain, but that's not the subject here. Two important things in export option. First of all, make sure you select the selected objects option to export only the selected object and not the entire scene. I can't tell you how many times I've ended up with a huge FBX file because I forgot to check this box. And finally, the Apply Modifier option must be checked before the famous long-awaited click on Export. Here we are in Unreal, and with a simple drag and drop I import the FBX file. I will just change the scale to 0.5. You can see that a message is displayed. So once again, I'm not an Unreal specialist, so I don't know what it's trying to tell me. If any of you know what it is, please clarify it for me in the comments, and it might help others too. I place my object in the scene and I configure the material. It's all about importing the metal map that wasn't imported automatically and connecting everything to the right place. After so much effort and an information dense tutorial, we've earned the right to have a little fun. Well, congratulations! You've made it to the end. I hope you have learned as much as I have. I really sweated on this tutorial, but I'm glad I could compile it all here to share my findings with you. You will find in the description all the links to my add-ons and those of my colleagues. Go through the... c'est dur. Aïe, aïe, aïe. Go through these links, subscribe, likes, share them. It supports the channel. See you next time, and don't forget, we get tired of everything except learning. Bye bye.